Have you ever heard of a black hole? It's not a hole, but a tiny, super heavy point in space. Its gravity is so strong that nothing, not even light, can escape, making it look like a spot of pure blackness in the sky. Imagine a bowling ball on a rubber sheet, making a deep dip. A black hole is like a bowling ball so heavy, it creates a bottomless pit in space. Anything that gets too close, planets, stars, even light, falls in and never comes out. A black hole is matter squeezed into a space smaller than a grain of sand, making its gravity the strongest in the universe. Scientists are fascinated by how something so powerful can exist. But black holes aren't born out of nowhere. They come from massive stars. The story of a black hole is really the dramatic ending of a giant star's life. To understand black holes, we first need to understand the stars that create them. Let's start at the beginning, the life of a star. This is a story of energy, gravity, and a spectacular collapse that gives birth to one of the universe's greatest wonders. When you look up at the night sky, those twinkling lights are stars, giant balls of hot, glowing gas. Our sun is a star, close enough to warm our planet and give us daylight. Deep inside, stars create energy through nuclear fusion, smashing atoms together to release light and heat. This energy pushes outward, while gravity pulls inward, creating a perfect balance. As long as a star has fuel, mainly hydrogen, it keeps shining for billions of years. Think of it as a cosmic tug-of-war. Gravity tries to crush the star, fusion pushes back. This balance keeps the star stable and round. But stars don't shine forever. When a star's fuel runs low, the balance tips. The star's life is about to get very interesting. What happens when the fuel runs out? That's when the real drama begins. As a giant star runs out of hydrogen, fusion weakens and gravity starts to win. The core shrinks and heats up, allowing the star to burn heavier fuels like helium and carbon. The star swells into a red supergiant, hundreds of times bigger than before. But burning heavier fuels is a desperate, short-lived effort. Each new fuel burns faster, and the star races toward its end. Eventually, the core fills with iron. Fusion stops, and gravity takes over completely. With no energy left to push outward, the star's core collapses. The outer layers have nothing to hold them up. The tug-of-war is over, gravity wins. The star is in big trouble. What happens next is one of the most spectacular events in the universe. The stage is set for a cosmic explosion. The birth of a black hole is near. With fusion gone, gravity crushes the star's core in less than a second. The core collapses to a space smaller than a city, the biggest squeeze in the universe. This triggers a massive shockwave, blasting the star's outer layers into space. The explosion is called a supernova, so bright it can outshine an entire galaxy. The supernova scatters elements like carbon and oxygen across the cosmos. But the core keeps collapsing, becoming a singularity, an infinitely dense point. This singularity warps space so much that nothing can escape its pull. A black hole is born, the universe's hungriest object. The supernova is its birth announcement. What was once a giant star is now a tiny, invisible powerhouse. The black hole's story has just begun. So, that's how a black hole is born, from the spectacular death of a massive star. Black holes aren't just cosmic monsters. They help recycle elements, shaping new stars and planets. They're both an end and a beginning in the universe's story. But black holes are still full of secrets. We can't see inside them. So scientists study how they affect nearby stars and gas. They're one of astronomy's greatest mysteries. Here's a mind-bending fact. If you fell into a black hole, time would slow down for you compared to the outside world. Black holes don't just bend space, they twist time itself. They're the universe's strangest time machines. And that's why black holes will always fascinate us.